So yeah, my name is Norm Dueck. I have my own consulting company, HeartLand Soil and Crop Solutions, that I started about 5 or 6 years ago, and I also do some contract work for A&L Labs. And over the last couple of years, been a good experience there too. A little bit about myself. I grew up on a small farm, Central America. Got a lot of different experiences there, and growing crops, obviously, from mixed dairy to poultry to corn, beans. Spent a fair bit of time in Manitoba, and then in '99 got to move to BC, and this is where I got most of my formal education as far as working with agronomy goes. Coming out of Vanderhoof, it's kind of exactly central part of BC. It's a beautiful spot. I do cover, for Heartland, I cover central northern Alberta, or sort of central northern BC, and for A&L, I venture into Alberta as well. I gotta make some acknowledgements here. I always borrow and steal slides from whoever I can. So if I haven't covered everybody, I'm sorry. I'll apologize later again if I stole somebody's slide that I wasn't supposed to use. But you get around the block a few times, you start collecting information from a lot of different people. So for me, and for any grower, farmer, it is all about the roots, and we've heard some of this stuff already today. I'm going to be overlapping a little bit with what Dieter and Josh pointed out. You'll probably see some similar slides and graphs, but it is about the roots. If we don't take care of that part of the crop, you're gonna suffer on the yield end of things quite rapidly. Soil testing. Why do we soil test? Well, there's a number of reasons. There's something that limits the yield in every field. In some cases, it is nutrient based. Not always. Sometimes drought can cause issues. Last year we had excess water in almost all parts of central BC, to a point where we were drowning crops. Sometimes too hot, can be too cold. Poor seed, poor quality seed, disease or pests. There's a lot of limiting concerns or issues in cropping, as most of you guys are very well aware. But I'm going to focus on nutrients, soil nutrients. I'm going to focus just on a couple that I picked out, maybe a bit of my my favorite few nutrients that I've looked into a fair bit in the last couple of years. So I'm going to start. The ones I'm going to hit are going to be potassium, calcium, and I'm not going to go too deep into what Josh already spoke about, but I'm a little bit of a different angle on that. Also boron, a micronutrient. And then I want to talk a bit about percent base saturations, as well as I'm going to round it off with nutrient removal rates of a couple of crops. So one size doesn't fit all. So you need to test your own soils. Don't go by what your neighbor says or what the guy down the street says, because not all soils operate the same. Your neighbor's soil is different than yours. Get your own soil sample. So here's something that I did. I just thought I'd just throw a couple of shots up there to indicate the variability we have in our soil. So this picture here, this field is my own field here on the home quarter section that I live. And in fall of 2019, I went and did a site-specific soil sample field. My wife and I spent the better part of 4 hours collecting 85 samples out of 85 acres. And it's a lot of dirt, a couple of coolers full of dirt, but I wanted to know what the variability was like. And not surprising, there's quite a variability in the pH in itself. So here's the two extremes. Lowest 0.5.4, highest 0.7.4. My intent had been to do a blanket lime application on this field, but I would have done almost as much damage as good if I had put on 2 ton per acre, let's say, on everything, because I would have raised some pHs far too high. This is potassium, again, quite variable throughout the field. I should go back one slide. I was going to point out that on this picture here, there was a fence line across here that went. The northwest corner is a hillside, and it's an old pasture. And then this corner here, this arm, was an old pasture as well. Quite different. This is a ridge, so very different variability depending on the topography of the soil. This is the potash numbers, percent base saturation numbers, and we're going from extreme low 1.2 to an extreme high of 12. Problems on both ends. Now, what happened here in the blue area This is an old feed stack yard. So there's a lot of nutrients deposited over time in that area. So I'm getting a very high reading of a bunch of nutrients, and in many cases way too high. The other slide I have is on, this is boron. Here again, extremes, 3.2 to 0.7. This 15 number here, I don't think that was right. There was something that I rested the following year. It wasn't that high, as around 3. So it could have been a typo in there. But anyway, so extreme variability in soils. Boron's kind of all over the map. I've got good boron levels, but I've been putting on 2 to 3 pounds per acre every year for the last 5 years. So I'm building boron levels. Now I got to start looking at it might be too high. So the first thing I want to talk about is base saturations. Dieter pointed out a little bit already. I look at base saturations on the soil sample quite a lot. I put a fair bit of attention on that. There's only so much space on your soil particle, and what are the nutrients that are attached to that soil particle is how I look at it, and how much is enough, how much is too much. You can also look at it as, you know, the board members in a corporation. Who are the board members? Who has the most influence? So on and so forth. Who do you want on the board to actually direct where your company, so to speak, goes? So I'm going to the base saturation numbers on the A&L soil sample on the top right hand corner. Got it blown up here a bit, and so this is a 2 different sample. If you add these numbers up, they're going to total roughly 100. Ideal ranges. Now this varies with the soil CEC. So in a low CEC, like we talked about earlier, if you have a coarser soil, you need less of the nutrient to be as effective. So in a lower CEC soil, your ideal pH or percent K might be between 2 and 3, or than 3 to 5. So these are very general numbers when it comes to ideal ranges. As you can see, this soil is quite low at 1.3. Magnesium, again, wide range. Typical is 12 to 15. This is for alfalfa. That's pretty much where you want to be. This soil is at over 21%, and in a soil where your base saturation of magnesium is greater than 20%, you're actually going to often you can find or see magnesium deficiency in a high magnesium soil, partly because magnesium makes the soil very tight, makes it harder for the plant to grab. But however, the other reason is that when there's too much magnesium in the soil, the plant will actually close the gates and say, I'm not taking any in because there's too much, you don't know what to do with it. So we've done testing in plant tissue in high magnesium soils and actually come up with deficient levels in the plant tissue because there's no way for the plant to take it in. What you can do in a case like that is you can actually trick the plant with applying a small amount of a highly soluble magnesium. The plant will open up and take it in again. Calcium, ideal 65 to 75. I did a lime recommendation for a client of mine, and we were aiming for 72% base saturation. That way it gives you a bit of a cushion to get that high. So we're starting to do some lime in the central interior of BC here, which is very promising. Hydrogen, I like this less than 10. Usually until here where it's 47.7 and 28.9 on the hydrogen. So typically when you have a high calcium or in this case, a low calcium soil, on the opposite end of the C cell, you'll have high hydrogen. And less than 10 would be ideally where you want to be. You want to have some hydrogen, but not too much. Hydrogen actually has, if there's too much, it can have a scorching effect on the root tips of a plant. Sodium, absolute ideal number is less than 1. I know you can be higher than that and be okay. Depends where your other nutrients are at. Anything over 3, I start getting very concerned, depending again what kind of crop you're growing. One side note on sodium: if you have your percent sodium higher than percent K, something really interesting happens in the soil, and the plant will actually start taking in sodium rather than in place of potassium. So when a plant does that, and now it's taken on sodium, and you end up in a drought condition, sodium as salt in your plant will cause a lot of damage or potential damage in drought conditions. So sodium may not, if this sodium was over 1.5% here, it could happen where we end up in a really negative situation with even with a lower level of sodium. I think this is something that Neil Kinsey pointed out in his book, Hands-on Agronomy. He had done some experimenting with high sodium and lower potassium, negative impact it had on crops. So to potassium, some of the benefits, yield potential is obviously impacted hugely by potassium. If you're growing barley or wheat, if you have enough potassium in your soil or in your fertility plan, you're going to get a plumper kernel that has a better bushel weight. Stalk strength is a huge one. This last summer here, I was a guy that I rent the field to, which the combine you can see in the background. We had barley in there again, and we ended up with a really nice crop of barley, but then in middle to end of July, we had a bit of a windstorm and rain come through. About 35% of the crop went down. Now I have good potassium levels, but I have some other things on the low end, and copper is one of them. So anyway, potassium plays a huge role in keeping that stalk standing upright the way you want to. Start losing yield really fast when you have a crop that's down. Improves winter hardiness, protein production, cell division. Again, like I said, 3 to 5 is generally considered to be the ideal range where you want that to be at. If you have, so nutrients take up, or plants take up nutrients in different ways. Some take it in through diffusion, other nutrients through soil solution. Potassium is through the soil solution. So if you have a high amount of K in the soil solution, your plants can readily take it up. So in a dry year, you can be negatively impacted by even if you have adequate potassium in your soil. Deficiencies appear first in older leaves, and this is generally what a deficiency looks like in potassium. It starts with at the tip of the leaf, usually, and works its way down. The outer margins of the leaf start turning brown and then white to the point where they wither and die if you have a potassium deficiency. And very common, it's one of the most deficiencies I see, the most common deficiencies I see in the central interior is low potassium. It also is involved in the signaling in the rhizosphere, nodulation, so on. Very important role that it plays there. This is a study that the NL Labs did. They spent, I think, 8 or 9 years doing a lot of research on a lot of different factors, and one of them was percent K saturation in soil. This is on a corn crop because from Ontario, so of course it's going to be corn. So when your base saturation was at 1.5%, yield was around 125 bushels. Consistently, when you brought your base saturation of K into that ideal range of 3.5 to 4, more than doubled the production in corn in this case. So very, very important to have that, to have your saturation the right number, to have the right amount of potassium in the soil for the crop to take. I think a corn crop like this at the peak season pulls out about 15 pounds of actual K per day. And if you don't have enough there for the crop to keep grabbing, and this is where there is always some limitations. In some soils, you cannot supply enough potassium for a 300 bushel corn, but other soils you can. So it depends what you're growing and where you're growing it. Calcium is the next one I'm going to go to. Calcium is known as the trucker of all nutrients. It's incredibly important, first of all, in soil structure, as Josh has referred to already. Cell wall strength again, overall plant health. It's just, I can't say too much about the value of the right levels of calcium in your soils, which of course means you'll have a good pH with that as well. Cell elongation, cell wall. Overuse of nitrogen makes a weak cell wall, whereas proper amount of calcium can actually counter that and give you a good healthy plant. Storage quality, disease resistance, all played into by calcium. Health soils require calcium in them. Here's the slide that Josh showed, slightly different version of it, same idea there. What you point out, if you get pH too high, your boron becomes less available. Too low, magnesium is a problem, so on. Common sense again. I like to see my pH between 6.2 and 6.8 for most crops is ideal. Quickly go to boron here. Boron, the reason I pick boron as the micronutrient is because the the important role it plays alongside of calcium and potassium. You can have all the calcium in the world in your soil, but if you don't have boron, the plant will have a hard time utilizing that calcium. Boron controls the efflux of potassium from the leaf. So if you're in a dry year, hot, dry year, you have enough potassium in your soil, but you don't have enough boron. The boron or the potassium will leach from the leaf back down into the root zone, and now the plant is susceptible to hot, dry weather. So boron controls the efflux of K from the leaf. Very important factor in a healthy stand. If you look at the pictures on the right-hand side here, this is coming out of Marshner's book, research he did probably back in, actually don't even know when, 50s, 60s. The picture on the left has adequate boron. The picture on the right is low in boron, and it's a cross section of a microscopic cross section of a plant stem showing the xylem and phloem where the nutrients travel up and down. So on the left-hand side, I look at them as plumbing. Those are pipes that are fit together. The juices are going to flow. Whereas on the left-hand side, on the right-hand side, it's all kind of scattered. They're kind of flowing into each other. There's nothing organized in that stem, and that's the difference that boron can make in a plant. So anytime you want to build stronger cell walls and get more calcium in the plant, you have to have boron in the discussion. Boron is the mortar, calcium is the bricks. Picture of boron deficiency in alfalfa, left-hand side, and then the right-hand side, root difference and the crop difference as well in canola, boron or without boron. Very, very big impact it's having. Quick little picture here, again, back to A&L's research. Once you have the boron levels in the plant tissue going up higher, your yield will follow. Then I'm going to make a bit of a sideway here into the removal rates of nutrients. And we're talking specifically about calcium, calcium, potassium, and boron for comparison. So a 3-ton dry matter of alfalfa crop will remove about 147 pounds of potassium out of your soil. Calcium, a lot less at 56, 57 pounds, and boron, 0.16 of a pound. So this 0.16 of a pound, if it is missing, it'll hurt your yield as much as this 147 pounds does if it's missing. So don't think that because it's a micronutrient you don't need it. You still need it, just in a lot smaller amounts. To give you an idea, 147 pounds of actual K would require 245 pounds of KCl, potassium chloride 0060, to replace that 147 pounds of potash removed. And you need 157 pounds of a 36% typical ag lime. So here between these two, we're at 400 pounds of fertilizer already, and I know most of you don't put that amount on in the field. We don't have to, for the most part, because our soils do release more and more all the time. But if we're continually going in a negative fashion, we're drawing more than we're taking, or putting back in, at some point, it's like drawing on your bank account. At some point, you're going to have to pay the piper. Wheat, for example, a lot less than potash, is still a substantial amount. 92 pounds for a 60 bushel crop. Calcium is very little bit, a small amount in there at 6 pounds. And then of course, boron is a small amount again. Doesn't take near as much to replace these, but wheat draws more phosphate, it draws more nitrogen, draws more other nutrients. So anyway, just in summary on that, why the focus on soil nutrients? To me, it's obvious. I've looked at it for 21 years here in BC, and I've seen our soil health generally deteriorate over time. Guys aren't looking after their soils for the most part. I've got a few guys now who are starting to do that more and more, and there's different ways of doing it without breaking the bank. You want to increase your ROI, you want to produce more forage maybe. So feed your crop what it needs. At stake is long-term health of your soil and future generations, and what are you leaving? What are we leaving for the next farmer coming along to farm this piece? Because I'm not going to farm it forever. So that'll I'll leave it at that. I think I snuck in there with my 20 minutes, and time for some questions.